So let's start with a very simple question. What is a software? People might say software is code. Actually, it's not just code. Software is a solution to a problem. For example, Uber solves transportation. Amazon, it solves shipping. WhatsApp, it solves communication. And Swiggy solves food delivery. There are a lot of apps out there that are solving some problem of the customer. Let's imagine you want to build a house. What do you think? Would the workers immediately start placing the bricks? No, right? Someone creates a design, then they will decide how many rooms are there, how many rooms are going to be there in the house, where is the kitchen going to be, where are the windows going to be, where do we place the staircase, how many stories the house is going to be. And only after the design is ready, then the construction begins. So we can relate it with the software as well. First we design, we decide the configurations of the software before writing the code. Once we have all the designs in place, we start writing the code. So what do we learn? Low level design is simply a blueprint before coding, right? Let's take another example. Let's imagine we are building a food delivery app. Before coding, we have to think about a few things. What things exist inside the application? Let's start with food delivery app. Let's just note down what are the things that we require in our food delivery app. First of all, someone who serves the food, that is the restaurant. After that, someone who consumes the food, the customer. After that, someone who delivers the food. Wait, before that, let's see. The customer selects what he wants to have from the menu, right? So let's add menu as well. After that, once the menu is selected, then the customer places an order. So we can have order in our application. Once the order is placed and the food is ready, it is given to a delivery partner. The delivery partner picks up the uh, food from the restaurant and then he delivers it to the customer. What else do the customer have to do? He has to pay, right? So these are all the features that my application have to have, or I must say these are the entities that belongs to my application. Saying feature is not the correct term, I must say. These are all the entities that are crucial to my application. Why I say that? These all these entities are fulfilling something at some point. So these are crucial entities and they must store some data, right? What should restaurants store? A restaurant can have its name, it can have its address. What else? It can have rating. Let's say like you see ratings of the restaurants in the food delivery app, right? And then we have something, a list of food, a list of items that they serve. We call it menu. Similarly, a customer can have different values, different features associated with it, like name. Then we have his phone number. Then we have his address. What else? Let's say he has been placing orders for a while. So let's say we have a history. Similarly, menu, order, delivery partner, and payment. They have their own list of items that are necessary for them. So, do you see what's happening? We are slowly discovering. What are we discovering? We are discovering the objects. and the values they should contain. That simply means without even writing a single line of code, we have already discovered the things that are going to be there in the application. And which brings me to a point that low level design is not just Java or Go or Python or any other language. It is rather a way of how we think before we write a code, right? Or in a very formal way, if I define low level system design, it is the process of identifying the objects in a system, then defining their responsibilities, and then deciding how they interact with each other. If I define it, low level system design is completely three steps. What are these three steps? It starts with identifying the objects. That's what we have done here. Restaurant, customer, menu, order, delivery partner, payment. These all are objects. And then their responsibilities. The restaurant's responsibility is to prepare food. The customer's responsibility is to order food. And then the menu's responsibility is to show all the list of items that are there in the uh, menu, or all the list of items that the restaurant has to offer. Our order's responsibility is to keep the crucial data, order data in it. The delivery's partner responsibility is to deliver the food from the restaurant to the customer, and all the data related to that is going to be saved inside delivery partner. The payment object is responsible for handling the complete payment, the payment modes, and the total logic behind doing the payments. So every object has responsibilities, and after that, the relations. How these objects are related to each other. So they are not standalone, right? They come together and create a system. So LLD is simply identifying the objects, then identifying the responsibilities, and then identifying the relations before we code. So if we do that beforehand, before writing a single line of code, things become very easy for us. And that's why it is a very good practice to design a system before coding it. Or I must say it is an ideal practice. Ideally, we should be doing things like this. So when I say that low level system design is very crucial for building software, do I mean that without low level system design I cannot build a software? No, that's not entirely correct. Even without low level system design I can build software, but here we are talking about quality, ease of understanding, easy extendability. Let me try to convince you with an example. Let's say this food delivery app was created when there was no UPI payment method available. So at that time we just had two payment methods available. That is a debit card and it was COD, right? Let's take a scenario where we are not trying to follow the low level system design principles and we are just creating uh, the application, let's say just with vanilla methods, right? I don't know if it is the right term to use here, but I think you get what I'm trying to say. Then let's say UPI was introduced. If we are not following any design principle here, there is a probability that in order to add this UPI functionality, I might have to change the complete payment code, right? Even when it was not needed or nothing changed in the other two methods. Doesn't that sound weird? Something that was working completely fine has to be changed just to add another method of payment. So, and if we add something, if we edit the existing code, we have to do the testing right from the scratch once again. Like, did we really need that? Can't we just design it in a way that we don't have to change the existing code and we can just hook the new functionality like a Lego? That's exactly what a good low level system design implementation solves. So if we are following some good system design principles, what we will do, we will design our system in such a way that even after introduction of new payment methods in our example, we don't have to do any changes in the existing functionality or code. We just extend it in a way that nothing existing will change and we just add new functionality up to it. This is called extendability and this is very important, right? Let's say there are 10 different people working on the same code, right? There are 10 different payment methods that we have to add to our functionality. We want to design the system in such a way that we just superimpose the requirements and then the 10 different developers can start working on it simultaneously without having to worry about uh, whether it will work in the future or not, right? This is the importance of a good low level system design implementation.